Okay. So go back to what I was saying before. So as I was saying, some definitions that we need to have an understanding of for this chapter. As I was saying, as far as elements are concerned, these are substances that cannot be broken down into simple substances by chemical means. Okay, everybody sign the sheet? Okay, by chemical means. All right. Now, these last two words are very important because it turns out that elements can be broken down into simpler fragments, but this would not be a chemical reaction. This would be a nuclear reaction where you literally change the composition of a nucleus. And because of those changes, you're basically converting from one element to another. In most cases, in other cases, there's no transformation in terms of the element itself, but there will be changes in the nuclear composition. So that brings us now to another definition, because each element is unique, right? And one thing that they have being unique are the different particles that are present. So in most atoms, there are three particles, or three types of particles. You have protons, neutrons, and electrons. All right. Now, in terms of the nature of these particles, let me start off by putting the mass here. Right? The mass of the proton and neutron are approximately the same, right? 1 unit, right? But the mass of the electrons, if I remember correctly, is about 1/1800 the mass of either the proton or neutron, right? I need to confirm this, but I think that's correct, all right? So basically what this tells you is that the electrons are lighter compared to the protons and the neutrons, which are equal to each other approximately. In terms of the charge that they carry, right? The protons will be positively charged, right? And in fact, let me erase this here. Will be a charge unit of 1. A charge unit of 1. Neutrons, as the name suggests, has no charge whatsoever. And electrons will have a charge unit of -1. All right. So the protons are actually +1, plus right. So the protons will have a charge of +1, neutrons have no charge, and the electrons will have a charge of -1. All right. So these are the basic fundamental nature of these particles. And what you'll find, in fact, let me create another row here. What should I call this? Location. What you'll find is that the protons and the neutrons will both be located in the nucleus. And the electrons will be located outside the nucleus. All right, so that's basically where these particles will be located in a typical atom. All right. So, as I was saying earlier, each element is unique, right? And they're unique because their atoms themselves are unique in terms of the composition of the particles that are present in the atom, right? And because of that, what you'll find is that each element will have their own unique number of protons. We get this here, right? So each element has its own unique number of protons in each atom of that element. All right. And there's a special name given to this number. It's called the atomic number, right? So you're right here that the atomic number is the number of protons in an atom of an element. All right. So each element has its own unique atomic number, right? And if you consult any legitimate periodic table, such as the one that we have here, you'll see that there are two numbers associated with each element, right? One of them, the lower one for each of them, would be the atomic number, right? The other one is called the atomic mass. We're going to deal with that later on, not right now, all right? So let's talk about the lower number, right? So for example, if I choose an arbitrary element like chlorine, right? Chlorine has an atomic number of 17, right? And therefore we can immediately come to the conclusion that chlorine has 17 protons in its nucleus, right? And chlorine is the only element that has atomic number 17, right? And that is true for the other elements that you will find in the periodic table. All right, so that's the couple of definitions that we have just covered, but there's some others that we need to talk about. Let me just clear all this here. Now there is another number that's associated with the elements known as the mass number. And by definition, the mass number is the sum of the numbers of protons and neutrons in an atom of the element, all right? Now the thing is, whereas the atomic number is unique for each element, that is not so for the mass number, because actually you can have two atoms which has the same atomic number, but their mass numbers are different, right? And there's a name given to such atoms. They are called isotopes. So isotopes are atoms having the same atomic numbers, but different mass numbers. All right. So let me give you a couple of examples. There are, as far as I know, 3 known isotopes of carbon, right? Before I even go into that, let me just say this first. All right. Now, there's a kind of universal convention that's applied when it comes to representing atoms according to their mass numbers and atomic numbers. And I'm just going to summarize it right here. So let's say A is the element symbol. The mass number would be placed up here. Typically they use the letter A to, no, I'm sorry, what am I? Let's say E represents the element symbol. Right, so this is the symbol for the element, symbol of element. And A is the mass number, right, which we talked about here. And Z is the atomic number, which we talked about earlier, all right? So in most textbooks, you're gonna see this kind of representation for a particular atom based on the mass number and the atomic number, all right? So, now I can get into some examples of isotopes. So there are 3, as far as I know, isotopes of carbon. You have this one, and finally this one, all right? So basically, they're all carbon because they all have the same atomic number, which is 6, right? So they're identical in terms of, the type of reactions that carbon would undergo, the type of compounds that would be formed, and so on, right? But the difference would be in the mass numbers. Whereas you have 14 here for this carbon isotope, you have 13 here, and you have 12 here, right? So if the atomic numbers are the same and the mass numbers are different, well, that means that the number of neutrons will be different, right? So if you were to calculate firstly, to calculate the number of neutrons, the number of neutrons would be the difference between the mass number and the atomic number, right? So basically, if you want to find the number of neutrons, if you know what the mass number is, and if you know what the atomic number is, if you want to find the number of neutrons, all you have to do is find the difference between those two, right? So if you apply that to each of these, what you'll find is that the number of neutrons in the case of the first carbon would be 14 minus 6, that would be 8. In the case of this carbon, it will be 13 minus 6, that would be 7. And finally, in the case of this carbon, it's going to be 12 minus 6, which would be 6, right? So the reason why we have different isotopes is because of the difference in the number of neutrons in the different atoms, right? Even though the atomic numbers or the number of protons will be the same, right? So that's basically how we end up with isotopes. Now, what you're going to find is that for pretty much all the elements that exist out there, they have isotopes. They can exist as isotopes, right? If you get any sample, for example, of that contains carbon, right? And if you can break it down into the different masses, you're going to get the isotopes separated. All right. Okay. So, is there something else I need to say? Mass numbers, atomic numbers, isotopes. Okay, I can't think of anything else to add. If it comes to me, I'll make a point of it. But right now, I'm going to give you assignment number 4. And assignment number 4 is basically a table, which basically is requiring that you complete it. They give some partial information, and then based on the information provided, you are to complete the rest of the table. So this is for you. And for you guys. Okay, and for you guys out there in Zoom, I've already published it. Let me actually bring it up on the screen. Okay, so this is it. All right, so oh, you didn't get one? Sorry. Oh, you didn't get one either? My bad. Give me one. Sorry about that. Okay, I'm going to help you with the first one, the first row. All right. So in the first row, they gave you the name of the element, they gave you the number of protons, they gave you the number of neutrons, and they gave you the number of electrons. Oh, I know there was something I forgot to mention. So as far as electrons are concerned, what you'll find is that in any neutral atom, the number of electrons and the number of protons will be the same. I should have made that point earlier, right? So you may want to make a note of that. In any neutral atom, the number of protons will be the same as the number of electrons, right? Now, later on, we're going to get into a discussion of ions where that is not true, right? But in the case of atoms, that is true. For neutral atoms, always the number of protons and electrons are the same. So, in this particular row, as I said before, they gave you the name of the element. They didn't give you the symbol. They didn't give you the atomic number. They didn't give you the mass number, but they gave you the protons, neutrons, and electrons, right? So the first thing I can write here is a symbol, right? And of course, you can use your tables to, find out what a symbol is. In the case of copper, that is Cu, all right? Now, the atomic number, we know that because we have the number of protons. By definition, the atomic number would be the number of protons. So 29 goes here, right? And the mass number is the sum of the protons and the neutrons, right? So that's 29 plus 5, 29 plus 35, and that's 64, right? So the mass number is 64, and that's it for that row, all right? So let's look at the next row. Let me hear what you guys have to say about the next row. They gave you the name, the symbol, the number of neutrons and electrons, right? So what would be the atomic number? 50. And we know that because we have 50 electrons, which would mean that the number of protons will be 50. All right. And what would be the mass number? 119. 50 plus 69. Exactly. And that's it. All right. What about the next row? What's the name?
Iodine.
Iodine or iodine. Okay. What about the number of protons?
53.
53. What will be the number of neutrons?
74.
Yeah, that sounds right. 74. And what will be the number of electrons? 53. Exactly. All right. So that's basically what you have to do for this exercise. So make sure that you complete the rest of it now. If you have any questions, let me know. And the same is true for you guys out there in Zoom. Make sure you complete this right now. And then what I'll do in the meantime is set up a validate solution. Dropbox. Okay, so let me go here. Okay. Yes, sir.
How do you find the number of electrons?
How do you find the number of electrons? In which ones?
For potassium.
Potassium, hold on, let's get it first. Well, the number of electrons will be the same as the number of protons. But let me check and see what you're talking about. Potassium, where's potassium?
This is A.
Oh, okay,
Yeah.
right. So in the case of potassium, they gave you the number of protons.
Yeah.
So the number of electrons will be the same.
Okay.
Okay, let me get back to. Okay, so this would go.
Each is silver. Been a while, but yeah. What's about iron? Yeah, we can't be serious, but. That's it. All right.
And let me just say, by way of announcement, so your first test is going to be next week, right? And I'm going to put some things in the announcement about, how to deal with the testing set of people and all that. But that test will be next week. So basically what you need to do is go to the website for the testing center and make your appointment. And you can do it at any of the testing centers between Levy here and Ocala, right? And that test will cover chapters 1 through 3. All right, so what we're doing now will not be on the test. All right, so the previous chapters will be on that test. And I'm sorry. Okay, so good question. The test must be done within the week of the 9th through the 13th, right? So Monday through Friday. So make sure you make an appointment. And let me just say this. So I got an email from someone from testing centers saying that in the past, students have not been showing up for their appointments, right? And that kind of creates a situation for them because, you know, spaces are limited when it comes to doing tests and so on. So please make sure that if you schedule an appointment for a test, that you meet that appointment. If you can't make it, I would suggest that you let them know beforehand so that they can, you know, provide spaces for other students who may need them. All right. I'm going to put all of that in an announcement which I'll post later on today. All right.
Yeah.
Understand? Did I send you guys back your assignment, your graded assignment 3? Okay, all right, just want to make sure. Because they're gonna need all of those to review for your test. Yes, sir.
I have a quick question.
Yeah,
Just so I know I'm good, correct, so, for simple A.
for which one?
K,
Potassium? Okay, yeah.
yeah, so you have 19 for your atomic number,
Mhm.
and then you fill out the rest, but how do I get to my mass number? I know.
Well, the mass number will be the sum of the number of protons and neutrons. So that will be 19 plus 20.
Next one. Okay. Thank you.
So that will be the mass number. Remember, folks, the mass number is the sum of the number of protons and neutrons, right?
Sure it is. Around. Okay, no idea. Or why, I don't know why, because the. What percent do ours? Oh. And you. Maybe. Yeah. Oh, it's like I put it. Do you know what I mean? Put it on, put it on fire, and then exploded the goo.
Alright, one more of those.
Yes, sir.
See,
Yeah. NI.
Okay, that's
When you
me.
have-
Hold on. Okay, yeah.
So you have 28 across the board and two, out, so it's two middle.
12 mass numbers.
Okay, so you're talking about this space right here?
Yes, sir.
Okay, well, that's the mass number, right?
Yes.
Thing is, you cannot determine the mass number without the number of protons. I'm sorry, you cannot determine the mass number without the number of neutrons. Right? So for that space here, since you don't have the number of neutrons, you cannot complete this here. So I would put something like Na here, And I think this is the space for neutron.
Yeah, so NA there as well.
Exactly, because you need one to get the other. So put like a dash or NA or something to indicate that you cannot answer that one.
Please. Or. You said it was 1.9. Yeah, or that. Yeah, it counts. Okay.
Yes, sir.
This is one of those, this is relatively off, so angles, so the last one is not changing.
That's not, you won't use that here for this,
Oh, okay.
right? Because as I said before, the second number is the atomic mass, right? That is different from the mass number. Two different things, right? Two different things.
All right.
Students very often confuse the two. In fact, let me tell everybody, so folks, listen up. Remember I mentioned that there are two numbers associated with each element in the periodic table, right? One is the atomic number, and the other one is the atomic mass. The atomic mass is not the same thing as the mass number. Two different things, all right? The atomic mass is not the same thing as the mass number, right? The mass number, as I said earlier, is the sum of the number of protons and neutrons present in the atom, all right? The atomic mass is something different. We're going to talk about that maybe in the next chapter. No, actually, further up, maybe chapter 6 or so, all right? So please make a note of that, right? The mass number and the atomic mass is not the same thing. Yes, sir.
On platinum?
Which one?
It says, platinum.
You mean platinum?
Yeah, sure. No, it just says 195.
Okay,
How do I work with that?
okay, 195, that would be the mass number, okay. So basically, for platinum, you go to the periodic table and you look up the atomic number. Where's platinum? Okay, platinum, 78, right? That's the atomic number. So right off, you can write down the atomic number there, and the atomic number would be the same as the
Proton.
number of protons, it should be the same as the,
Electron.
exactly. All right?
Thank you.
Mhm.
That's last. Yeah, remember how well I'm gonna keep it. Yeah, so. I worked there. Where? Oh, yeah, that's right. You were right. I was gonna be asking. Oh, yeah. I was gonna say, why is he over here?
You guys having fun back there?
Yeah, I'm trying to catch up. Yeah. So. Now, we only use like 100. I have no idea. That's not it.
Is it possible to have zero neutrons?
Yeah, hydrogen.
Okay.
Yeah, in fact, hydrogen is older than that guy.
Oh, yeah.
Only, one proton, one electron. Everybody sign the sheet?
Yeah.
All right.
What is it? Yeah. Oh, I do.
Wait, the 195.
We don't even know what it says. Alright, scenario, what if you have the atomic number, the protons and the electrons, you don't have the mass number or the neutrons.
Okay, hold on, let me,
So only four.
Doesn't have
which one are you talking about?
the one that has three quarters on. It doesn't have a, electron doesn't have symbol for and name of the element. Yeah.
What's the name of the element?
It doesn't have it.
It's just
It's right.
right there in the middle, four,
Right.
four, four.
Oh,
Yeah.
easier? Oh, okay. Well, the first four, I think, is the atomic number, right?
Is that beryllium?
So you'd have to go to the periodic table, and that would be beryllium,
Yeah,
Wait.
Be. 4.
you found it.
Yeah, you go to the periodic table, and you see which element matches up with that atomic number. So here you put beryllium, here you put Be, that's 4. And this is for is the proton, which will be the same, and number of electrons will be the same. So this is one of those situations where you don't know what the mass number is, right? Because you don't know what the number of neutrons are.
They're not available.
So again, Na, I will put there.
Alright.
Again, if you don't know what the number of neutrons are, you cannot get the mass number or vice versa. All right?
But anywhere,
Hmm?
but anywhere for the beryllium.
Yeah, here and here. This is, hold
Yeah.
on, let me check on it. This,
5 hours straight.
yeah, that's the mass number. This is where the mass number would be, this is where the number of neutrons will be. If you don't know one, you can't know the other.
Exactly.
So if you have that situation, you would go and
Exactly.
Same class, so it's 2 hours and 30 minutes.
You put any on the neutrons in it?
Yeah.
They give us a break of 7 hours.
Oh,
thank God. Oh. I what I mean. And the beach. Yeah, honestly, it was fine. I was so much on my still far. I would have you, I would have house over there. Now, but I still want
Yes.
How do I do this? I know this. Is that? I don't see it. I have it. It's not see. I don't know how to. He's like 130 days. That's right here. If you bring this kid in.
That is a good question. How does potassium?
Or those what?
How does the water contain equal potassium?
Oh.
Cause it's based off the old,
I think it's from a Latin, if I'm not mistaken.
Yeah.
There was I don't remember the word for potassium in Latin. It starts with a K and therefore it's just a holdover from that. You have a lot of examples of that in the naming system.
that was in the slides.
Oh, right, yeah.
I also forget what.
Well, if you're finished, that's pretty much all for today. You're gonna submit it online. Yeah, so the deadline for that is day after tomorrow, so make sure you submit it by then.
That I'm not saying. I think you this, that ever something, it's like, it's this, you know, yeah, 30. We're really big back, so yeah, so you're not. Yeah, it's not a need to, yeah. You need to feel, yeah, I see even see it. They should be on this last year, well, I found it's forever, right? I mean, that's it.
Yeah, it's very active.
You too, take care.
You think the best thing is to like start to change that?
Well, I would, if I were you, review the assignments that I have sent back to you. I think I've posted the answer keys. Let me check and make sure.
I think people should have.
Let me check and make sure that let me see. Because I would suggest you review those as well. Answer keys. Okay, so let me publish the answer key for assignment number 3 right now. Okay, so I would suggest that you review the answer keys as well. And also review questions from your textbook. Try to do as many as you can from the end of chapter questions. If you do all that, you should be in good shape. Oh, somebody's saying something in the chat. Do we need anything on the test? Oh, okay, so as far as somebody's asking about what do you need to bring to the test, the only thing you need to bring to the test is a calculator and your pen to write with. You'll be provided with the test itself and the table, the same tables that I've posted in Canvas will be available to you as well. Periodic table and all that good stuff. All right, sir?
Third, you'll get off.
Yeah, you'll come to me. Yeah. Yes, sir. Yeah,
Thank you.
all of that will be provided. The conversion table,
Those will be on there.
yeah, you don't have to memorize all that stuff.
Appreciate that.
Have this.
All right, take care.
Have a good one.
Yes, sir. Okay, somebody's asking something in the chat. Oh, yes, take care, Miss Chen.
Have a good day.
Yeah, you too, take care.
Question about the test.
Mhm.
Is it gonna be like multiple choice or essay?
It's going to be similar to the question that you did in the assent.
Okay,
Right.
okay,
And I'm going to try to make it a question per chapter.
a question.
So, yeah, so those 3 questions.
Okay, so the test will not be long?
It should last more than 75 minutes.
75?
Yeah.
Around how many questions?
3 questions in different parts, just like in the assignment. In fact, let me also post a past test question.
It's like a practice test?
Yeah, let me see if I can.
Thank you so much, I really appreciate it.
Okay, so I see a folder here which says test answer keys. See here. All right, I'm going to publish this folder which says test answer keys. Which is right here. Okay, so yeah, go there and then look for test number 1. Right here. And this is it. Right here. First question, perform a mathematical operation expressed in the correct number of figs. On these numbers to indicate the number of figs. Conversion from Celsius to Kelvin, density. This is some other conversion. Yeah, so this will be a good,
Awesome, okay,
guide to help you to
so how many questions?
well, 3 questions when they come in parts. So as you can see here, for example, this is question 1, and you have A, B, C, well, A, B in that case. And then question number 2, A, B, C, and then question number 3, A, B. That's it.
Awesome, thank you so much, will it be timed?
Yeah, 75 minutes. You get some
75.
time, right, to do. Yeah.
Yes, sir, thank you so
All
much.
right, no
Have a good
problem.
day.
Yeah, you too. All right.
How do you schedule the testing center?
I haven't done it myself, but from what I was told, you have to go to you should be able to find the testing center link on the college website.
Okay.
And then I think you have the option of Citrus, Ocado, or Levy. And then you
just have.
and then I think they have the slots there and you just choose which one.
You just schedule it by the 9th then.
Yeah. Well, the 9th to the 13th. Yeah, that week. So that's from the Monday through to the Friday. So you can schedule it at
I was
any,
gonna say, I wonder if they could get slammed.
well, if there's any issue, let me know.
Yeah,
But I know that they have had issues before. And like I said, they were saying that some people don't show up. So-
yeah,
So they were saying that you know, make sure you show up for your assigned dates. If not, let them know beforehand. So that they can make the appropriate arrangements.
then, what is it, let me see. So your office hours are. Oh, so your office hours are in Ocala.
Yeah, I'm between here and Ocala. Now, there's an issue with Ocala. I don't know if you heard, but
Yeah, they
Building two.
sent emails about.
right, the water situation, yeah. So I'm thinking because like tomorrow I'm supposed to be there, but I can't enter the building. So I'm thinking that I would have office hours online tomorrow. Cause I'm,
That would be just doing.
yeah, just so, I'm supposed to have a lab class tomorrow.
Oh,
So it doesn't even make any sense to go there tomorrow. I'm just going to see if I can find an alternative exercise for my students. Ah,
so is that the Chem 2045?
lab.
Yeah, 10 Chem 2045.
Lab, yeah, tomorrow.
Yeah,
Wait, today's what? Today's,
the third Tuesday.
no, I have Chem 2046 tomorrow.
Okay.
Lab.
Well, just because I have my second semester kind of ironed out of what I'm gonna be choosing,
Oh, okay,
and which Chem 2045 is.
yeah, okay. Well, I think I'll be teaching that, what, next one? I think I'll be teaching that here. I'm not sure if I'll be teaching it at, Citrus as well.
Yeah, I have Chem 2045 calculus, Spanish.
Oh, so you're doing calculus, that's good.
Yeah,
Calculus, I mean, even though it's not required for Chem two, but it will help.
well, it's I mean, it's required for electrical engineering.
Oh, okay,
Which that's what I'm going for.
Okay.
So
oh,
the plan is to do an upper graduate transfer to USF
okay.
as soon as I can.
Mhm.
Just because ACET, I think it is, the accreditation.
Right,
I need to talk to USF and see what actually transfers, because I know was that accreditation at a certain point. Like the classes CF provides aren't good enough for that.
oh, really,
accreditation.
oh, okay.
So it might be like they could be named the same class, but
Mhm.
since they're not accredited,
Mhm.
it does not matter, it won't count, so. And I'm pretty sure from what I've looked into, which I still gotta talk to USF, that after 2 semesters, that's it, that's all I can do at CF. For it to count towards my engineering degree.
Right.
So even though CF technically acts like you can do 2 years here. At least from what I've read into, it seems like after 2 semesters, it kind of locks you out.
You're right, yeah, I've heard of that situation, not only for engineering, but for other majors as well. So some courses here just don't transfer, but and that's an issue I have with UF because UCF and USF, they have been pretty good in terms of
Well, I'm doing USF.
right,
Yeah.
they have been pretty reasonable in terms of accepting credits from here.
Yeah, well, that's. But,
At least for some of the majors.
well, that's the thing is that they'll accept the credits, but. The engineering accreditation might not.
Oh, okay, so you say, okay.
Because
okay.
technically they have specific ways that the classes need to be taught.
Mhm.
And that's what the accreditation is for, is to show like, hey, we are doing it properly. And which that's what some schools don't like,
Mhm.
and that's why they don't even go for the accreditation,
Right.
because they don't like being told how to teach classes.
Mhm.
And so it's. We'll see how it goes. I need to do my Spanish though still. And cause I didn't do it in high school. And but yeah, luckily I was able to skip to U and college algebra because my placement scores were high enough.
Mhm.
So
Mm.
the orientation lady in Ocala, she was trying to be like, well, it shows right here when I was applying for the classes. Because it was a hold on my account, they're like, it shows right here that you need to do the prereqs. And I was like, no, it says prereq, oh, you know, placement tests and stuff. And she kept like arguing with me, and I was like, and then luckily though, the Alicia Johnson or whatever, she came and then she's like, no, we can force it. She's like, yeah, you got high enough scores.
Right.
It just sometimes doesn't register. So, and then I had to wait to get, because for some reason I got put out as undecided. And luckily
I mean,
they,
in terms of the major?
yeah, luckily they fixed into the engineering.
Oh, okay.
And but yeah, the plan is to do electrical engineering. I mean, I like math, so
Well, you definitely would like electrical engineering in that space.
yep. And I've been looking at what kind of stuff I get to do with the post here and stuff.
Yeah,
All the fun little equations.
oh, yeah,
Yeah, nice one, thank you.
all right, take care.
Is for sure. Jackson lines up with the 1500 point out. First capture Roger. Always up to the top of the train on the. He's